Hello. All right. In this particular video, I'm going to extend a little bit more on what we went over with logarithms. Okay. So let's say we want to consider this particular function. This is log base 2 of x. And there's a whole bunch of table of values here. So all the points on this graph are the same as what we have here, as well as some that are added as well. Okay. So let's say we want to consider each of the following expressions here. So I'm just going to tell you that all of these expressions that you see here are true. Okay, so if we're trying to look for a specific pattern between what we see here, so as you can see here, this 2 times 4 equals 8. We have 0.25 times 4 equals 1. Here we have 2 times 5 equals 10. And we have 2 times 3 equals 6. Okay, so put simply, what we can do is we have this rule here. So this is called the product rule for logarithms. Okay, so as long as the bases are the same, what we have on the inside here, you can multiply them together, and then you can create what you see in the inside there. Okay, so for example, right, it doesn't have to be these numbers. You could try different ones. If you tried log base 2 of 3 plus log base 2 of 3, well, 3 times 3 is 9, so that should equal log base 2 of 9. Okay. Similarly, let's see what else would it be on here. Maybe something like log base 2 of 0.5. And then you add log base 2 of 6. So 0.5 times 6 would be log base 2 of 3. Okay, so that's how the product rule works. Okay, the other rule I want to show you is this one. Okay, so that's a rule when you're adding. So coming here, this is a rule where you're adding. Okay, now let's consider a different rule which says what happens when you subtract. Okay, so if you were to subtract given this same graph, okay, so what I see here, well, 8 divided by 4 is going to be 2. Okay, 1 divided by 4 is a fourth, 0.25. So 10 divided by 5 equals 2. And 3 divided by 6 equals 0.5. Okay, so if you see a minus sign instead of the plus, so you see you have a plus here. So instead of if you see a minus sign instead, that implies that you can use the quotient rule. Okay, so the quotient rule basically says you can take the insides here and then you can do division. And that says that's true. You can try this with a whole bunch of examples if you wanted to. You could try something like, what's on here? Let's see, you could do log base 2 of 10 minus log base 2 of 2. And you get 10 divided by 2, which should be log base 2 of 5, for example. Okay, anyway, enough of me just trying to talk about this. Let's try to do some examples. Okay, so let's say we want to condense the following examples into a single logarithm. Okay, so let me write those two rules for you guys, just to reiterate what we went over. Okay, so log base b of m plus log base b of n. So log base b of m plus log base b of n is equal to log base b of m times n. Okay, so what we have here, so as long as the bases are the same, you just multiply the insides. Okay, so what is 5 times 3? Well, 5 times 3 is 15. So this is log of x of 5 times 3. And 5 times 3 is 15. Okay. This one, as you can see here, again, the bases are the same. So you just multiply 20 and 6. So 20 times 6. So log base x of 20 times 6. 20 times 6 is 120. Okay, come here, same idea, 15 times 4. 15 times 4 is 60. Log base x of 15 times 4. and 15 times 4 is 60. Okay, that's all there is to it. Okay, so remember what I mentioned earlier. Now, if there's a minus sign, this rule changes. Okay, so I'm going to change this to a minus sign. This rule changes, and instead of m times n, this is going to be m divided by n. Okay, so this one, we take log base x, and this is 28 divided by 4. Okay, so 28 divided by 4 is 7. So log base x of 7. This one here is log base x of 60 divided by 5. 60 divided by 5 is 12. Okay, I'll write that a little bit nicer. Sorry, I know that's not very nice. This is a log. Yeah, so this is log base x of 12. This one here, log base x, 98 divided by 7. 98 divided by 7 is 14. Okay, so that's how you would do that one. Okay, now what we're going to do is we're going to go ahead and mix up these practices. So I purposely showed you a whole bunch of addition first and a whole bunch of subtraction after. Okay, this one, what I see is we can multiply. So this is log base 3 of x times 4x. So x times 4x is 4x squared. Okay, with this one is log base 4 of x raised to 9 divided by x. X raised to 9 divided by x is x raised to the 8th. Okay, this one, log base 5 of 44 divided by 11. 44 divided by 11 is 4. Log base 5 of 4. So actually all these here, you don't even need to write the parentheses. If you are, or actually maybe this one you need to write parentheses, maybe this one. But all these here, you don't necessarily need to write parentheses. I'm just putting it there just for good practice. You know, like just if you guys getting used to it first. Okay, this one, addition implies we're going to multiply. So this is log base 7 of 8 times 15. 8 times 15 is 120. Okay. This one, log base 11 of 8x raised to the 5th divided by 4x squared. Okay. If you do this out, 8 divided by 4 is 2, and x raised to the 5th divided by x squared, this is going to be 2x cubed. So this whole thing becomes 2x cubed. Okay. This one here, so this one is log base 6 of 3x squared multiplied by 5x raised to the 7th. So now we multiply. So 3 times 5 is 15. X squared times x raised to the 7th is going to be 15 x raised to the 9th. And there we go. Okay. So that is the first part. Okay. So I'm going to show you more examples. A new row actually. After this. I'll see you later. Okay. Hello. All right. So let's talk about one more logarithmic rule. Okay. So recall that, you know, like if we combine like terms, so each of these terms all look the same. This is basically, if you think about it, this is 1 times x. If let's say x is equal to log base 2 of 4. So this is 1 times x and 1 times x. So 1x plus 1x plus 1x equals 3x. Okay? So if you add them and combine like terms, this is 3 times log base 2 of 4. Okay? Similarly, like I showed you earlier with the product rule for logarithms. So the product rule for logarithms, if you have something like this, basically the way the multiplication works, this is 4 times 4 times 4, because we just multiply the insides together. And that would be, well, 4 times 4 times 4 is 4 cubed. Okay, so that's going to be that right there. Okay? So what this says is these expressions here are the same. Okay? So we have 3 times log base 2 of 4 equals log base 2 of 4 cubed. Okay. Similarly, let's say we did another example. So let's say we had log base 7 of 2 plus log base 7 of 2. All of these terms, they all look the same. So one way to think about it, let's say we made a variable. Let's say x in this case equals log base 7 of 2. So if we did x times x plus x plus x plus x plus x, we get 5x, right? 1x plus 1x plus 1x plus 1x plus 1x equals 5x. Okay, and that's simply done by combining like terms. Okay, now if we change it up, so like I have here, as long as the bases are the same, all the insides here, so this is log base 7 of 2 times 2 times 2 times 2 times 2. Okay, so that means this here, if you were to change it up, 2 times 2 times 2 times 2 times 2 is 2 raised to the 5th power. Okay, so as you can see here, these expressions are both the same as what we see here. Okay, so we can imply that these are the same. Now, if we look for a specific pattern between each of the expressions that we created here, okay, what this says is, as you can see here, if you have a 3 here as an exponent, we can bring that down, and that's how we get the 3 there. Okay. Similarly, if we see a 5 here, we bring it down. That's how we get the 5 there. So this is a special property for logarithms. This is called the power rule. So anytime you have something of this form, if you see an exponent here, we can drop it down, and you have it r times log base b of m. Okay. So this one is pretty straightforward. Let's go ahead and do some examples. I'm going to rewrite each logarithm using the power property. Okay, so basically what I'm doing here, just taking this, bringing it down. 3 times log base 4 of x. Okay, take this exponent, bring it down. 8 times log base 15 of x. Take this here, bring it down. 14 times log base 7 of x. Now take this, bring it down, x times log base 2 of x, log base 2 of 3. Okay. Take this x, bring it down, x times log base 12 of 8. Okay. Take the x, bring it down, x times log base 6 of 8. Okay. That's all I'm asking you to do for this one. Okay.